Today we're going to talk about section 3.1, relating graphs to events. And you're going to talk about interpreting and sketching graphs that represent real-world problems. So everything that I have on, that you see on the screen, you should copy into your notes. So you should title your notes 3.1, relating graphs to events. The vocabulary words that we need to cover in this section are line graph, linear, and nonlinear. A line graph is anything that compares two things over time. So the time is what you want to remember. So it's a comparison of two things over time. So if you're comparing how many miles you drive in an hour, that is a comparison of time. Or how many math problems you do in a minute, or how many words you can type in a minute. Those are all comparisons over time. The word linear, if you look at the word linear, you will see that it has the word line in it. And that means that when you graph a linear equation, you are graphing a line. So it's a graph of a line. And nonlinear means when you graph it, it's not a line. So the graph is not a line. And you want to make sure that you get that into your notes. Okay, these are the examples that come straight out of your textbook on page 82. So if you'd like to follow along, you can. If not, you can just listen to the recording and copy the notes into your notebook. So example 1 gives you a graph, and the graph is the altitude of a helicopter during a flight. So if you see, we can compare the time and the altitude. Now it says, when is the altitude increasing? So if we look at our graph, we can see that the altitude increases from here to here. So that means between 0 and 10 minutes. So we're going to say 0 to 10 minutes. It increases. Then it says, when is the altitude decreasing? So that would be from this point to here, it's decreasing. So that's from 10 minutes to 20 minutes. Number 3 says, when is the change in altitude linear? That means that it is an actual line. And if you look at your graph very carefully, you will see that it is only a line from 5 to 10 minutes. If I look right there, I will see that it is a line, and then from 10 to 20, it's a line. If I look from 0 to 5, you will see that from 0 to 5, it kind of curves, so it's not linear. So we are going to say that when is the change linear? We're going to say 5 to 10 and 10 to 20. And then when is it nonlinear? We're going to say 0 to 5 minutes. Okay, example number 2 says, Kim measured her pulse rate occasionally during a 45-minute workout. The workout included a 10-minute warm-up and a 10-minute cool-down period. Sketch and label a graph showing her pulse during her workout. So if I look here, I can see that it was a total of 45 minutes that she was working out. Whoops. It was a total of 45 minutes that she was working out, and it had a 10-minute warm-up and a 10-minute cool-down. So if I go ahead and draw my graph, I'm going to compare the time that she worked out, and that's in minutes, to her pulse, which is in beats per minute. And again, you want to make sure you write this down in your notes. Now, it was a 45-minute period, so I'm going to count by 5s. So I'm going to go 5, 10, 15, 20, 25, 30, 35, 40, 45. And her pulse rate per minute, I'm not too worried about. So I'm going to just think to myself, what would your pulse look like? So you're starting your workout and your pulse is normal. Then you work out for 10 minutes. So your pulse is going to go up as you warm up. Then during your workout, your pulse stays the same. And then the last 10 minutes of your workout, your pulse is going to come down because you have a cool down period. So this is your warm up. And then this is your workout. And then this would be your cool down. So make sure that you have this in your notes. Okay, this is your check for understanding. It says a student wants to sketch a graph that shows the distance of a bus from the transit center during the morning commute. The trip includes 3 stops where people might get on and a highway where the bus travels at 50 miles per hour. So let's look at our important information here. They want to sketch a graph showing the distance, so we're comparing distance of the bus from the transit center during the morning commute. The trip includes 3 stops, so that's important, where people get on and a highway where the bus travels 50 miles per hour. So we have 5 questions we need to answer. Number 1 says, why should the student use a line graph? So think about what the line graph compares and answer that question. Number 2 says, what label should the student put on the horizontal axes? So think about what you should put on the horizontal axes. Number 3, when is the line on the graph parallel to the horizontal axes? So what would be happening in this situation where the line is going to be parallel to the horizontal, which means it's going to be a horizontal line. Just like in the previous problem during our workout, that was a horizontal line because her pulse wasn't increasing or decreasing. Number 4, when is the line farthest away from the horizontal axis? So when is the line you're drawing far away? And number 5, which section of the graph should be steeper? The section for the bus on the highway or the section for the bus in the city? And explain. Pause the recording, answer these 5 questions, then play the recording again to get the answers. Okay, number 1, why should the student use a line graph? A line graph is used, like we said before, when you are comparing changes over time. So because we're talking about time here, we are going to use a line graph. Number 2, what should go on the horizontal scale? That should be your time. If you had the vertical scale then, would have your distance. So the distance would be going up. Number 3, when is the line on the graph parallel to the horizontal line? That would be when the bus stops. So when the bus stops, its distance is not going anywhere. It's staying the same distance away. Number 4, when is the line farthest from the horizontal axis? That means when it is farthest from the transit center. So during your trip, when it gets farther from the transit center. That's when it's going to be the farthest away. And number 5, what section of the graph should be steeper? The section for the bus on the highway or the section for the bus in the city? Well, the steepness means that it's going away faster, so the fastest speed would be when it's on the highway.